So today we are going to discuss about how we can use the 8051 microcontroller to make addition of two hexadecimal numbers through using a microvision file using a file in assembly language. So let's begin it. I am opening Gale microvision file. So here is a preloaded program, and so what I am going to do is I am going to open this project, new microvision project. As you can see, I am going to make this project in this local disk drive E, and I make a folder. I am renaming this folder as addition. So I renamed it as addition, and now I am going to open it, and now I am going to create the file name. What will be the file name? I name it as addition 1. So this is the name of our new project. Now what kind of microcontroller we are going to use? We are going to use Atmel 89C52. So let's type it out. Sorry. So the chip is AT89C52, Atmel 89C52. This is the chip 8089C52. We select it. You see the description here. 8051 based fully static 24 MHz CMOS controller with 32 input-output lines, 3 timers or counters, 8 interrupts or 2 priority levels, UART, 3 level program memory lock, 8 kilobytes flash memory, 128 bytes on-chip RAM. So I selected OK. So copy startup.a51 to project folder and add file to project. Now as I mentioned before, at the beginning of this project, that we are going to make this file in assembly language, so we select this option no. So now we are going to begin it here. I press Ctrl plus N, or you can come here and see this new file. Now we make a program org 000. So we move a comma hashtag 02. Next we add A, comma, hashtag 03. Next, we show this thing at port. So let's say I am going to show the output at across the port 1. So I type move P1, comma, A, semicolon. Next we type END, end. The initial line should not have any semicolon, so I am deleting it. Now I save it. I save it as a C as a assembly type file. So addition, sorry, I save it as save as addition. I save it as a hex file. So addition dot assembly language file it is. So addition dot asm, and I save it. So now you can see it has been converted into a assembly language file. So I now create the target. So source group, I need to select an assembly file. So what I did is I double clicked on the source group and I add files for source group 1. So I select this addition.asm that we created just a second before, just a moment before, and I select the add, and it's added, and I close it. So now the moment I click at this addition symbol, I can see the addition.asm file popping up here. Now I select the target and right click over that, and options for target 1 I select, and I select the crystal frequency as 12 megahertz, and I use the on-chip ROM, which is this, and which is 0 cross 0 to 0 cross 1 FFF. This is the on-chip ROM. This is the range 0 from 0 to 1 FFF. So now the next thing I do is I select the target and the output. I select the output and I select the base hex file. So hex format you see hex 80. So now I select OK, and now I build the target. Here I select this build, and as you can see there is no warning, no errors, and it has been successfully compiled. Now I minimize this window and I open the Proteus 8 Professional software, which I have downloaded from a website. I click yes, and here we go. So I create a new project here. How? I am going to make a schematic capture. So I click this particular icon, schematic capture, and as you can see here, loading PSM debug, and it is just about to start. Yes, so this is what we have here. So now this is your Proteus 8 Professional schematic capture window opened, and now I select this parts and keywords. I select AT89C52. This is the microcontroller that we are going to use. Okay, 8 kilobyte code, 256 bit data, 33 megahertz, and 3 cross 16-bit and 3x 16-bit timers. This is a microcontroller that we need right now. So I select it, OK, and I put the microcontroller here, and now I need some LEDs to see my output. So I select the LEDs. Which one to select? This is a question. So I select this, or I can select this. This one is the green LED. You can see the part getting selected here, and the associated schematic model is being shown up here, and here is the PCB preview which we saw just a moment before for this microcontroller. And now I am going to use this one. Let's say that I am going to use this green LED. So I take this green LED, I put it here, click it here. Again I take another one, another one, another one, another one, another one, another one, and another one. So we have 8 LEDs altogether. So now I am going to connect it, make the connections. So as I had written before, I wanted to show the output across the port 1. So I am going to select it. I am going to give the positive voltage from here, from the microcontroller pins. I am going to give the positive voltage to these LEDs. So I connect the anode. This one is anode. This one is anode. So I connect it with pin number. As you can see, I hope you can see it clearly. Pin number 2. I am zooming it a little bit for your benefit. So as you can see, this one is the anode. I click it and draw this line and connect it with this one, which is pin number 2 from port 1. Now pin number I click it here and just bend this line and the 3 number pin of port 1, and I take this here and the 4th pin, and this is a very fun game, at least for me. So here I can select and hover over the entire image. So I select it here and I connect. Sorry, if I mistakenly pick up a part and don't want to implement it here on the schematic, so I press the escape button and it goes away. So I select the 7th pin and take this line and I join it, and again I take this and this line goes to the pin number 8, which is P1.7 marked here. P1.7 is referring to the pin number 8 of the microcontroller, and now I have to use a ground so that I can altogether ground all these cathodes of all these LEDs successfully. So I select a ground. So where I can find the ground? I can find the ground here, the sub-circuit node across here. So I can select the ground. So I take one ground point and I connect all the LEDs cathodes respectively with this same wire, same line, so that they all get grounded and they all have the ground connections associated across their cathodes. As you can see, I am grounding them. So I take this here and it's grounded, and I take it here and it goes. So done. I select it and escape. I select it and delete it, and it goes away. So now we are complete with the schematic capture with the entire circuit station. We are completed. Now let's make the hex file loaded into this microcontroller. So what I am going to do is I am going to right click over it and I select edit properties, and here I am going to select this program file. As you can see here, I am going to select the folder where I am going to find it. I am going to select the local disk drive E, and here I had made the, as you here you can see the addition folder. So objects, here it is. Yes, here it is. Addition1.hex. This is one I had made. So I open here. As you can see, the program file has been uploaded. So now I select OK. Now I am going to play it. What's going to happen? Oh, there has been a mistake by me. Sorry, I had not connected this particular point. So I am going to stop the simulation and connect it with the ground, this particular cathode, and now we are done. So yeah, bingo. What did happen here? Let me explain it. So I am going to open it here. So what we had done is I had moved this particular data 02, which is a hex file. So I had moved this 02 hex file to the accumulator, and then I had added the 03x file with this accumulator, and when I use a hashtag, the hashtag means the data. So the data 02 is added with data 03 and it is a hex file. So this results 05. So if I have to implement 05, so you see, if I have to implement this file, this 05, which is in which is a hex file. So if I have to make it, so you know the breakup. The breakup in binary is 8, 4, 2, 1. So this is the breakup. Now I am going to rotate it a little bit. Here you can see it. So this is how it looks like. So you see that the 8421 is the breakup, and we have to show 05. So what we are going to do? We are going to mark it in terms of LEDs. So this is the 4 and this is the 1. So 4 plus 1 equals to 5. So 4 plus 1 equals to 5. So this 1 represents, let me open it here. So this, as you can see here, just compare these two images correspondingly. You see this 8421. You see this 8421. Just look at the configuration, how it has been done. The LEDs, the pin number 0 of the port 1, this is the first LED which is representing this 1. Now the 2, 8421's 2 is associated with the second pin which is this LED, so 2 is off. So here the second LED is off. Now the third one, 4 has been marked as with a circle, so this one LED is on. Now the next LED 8 is off, so 8 is off. Rest of LEDs are all off. So why this happens is because we are creating a hex file. Now hex file is a 16-bit file. 16-bit means 8 plus 8, if I am correct. Sorry, that's a different issue. Let's look at it in a simple way. So the 8421, the 4 plus 1 equals to 5. So we have added 4 plus 1 equals to 5. So this is how these two LEDs are indicating. This one LED is the LSB, or the least significant bit, and the third LED is representing the MSB of our result. This is the additions result, this is the result, and this is results. Breakup is this 4 plus 1, 1 is the LSB and 4 is the MSB. MSB means most significant bit and 1 means least significant bit. So here is how we can use the LEDs to show the output of two numbers. Hope you like this video, and if you want more, then please subscribe my channel and also press the bell icon so that I can keep uploading such videos and get some inspiration. Thanks a lot for paying your kind attention and time to this creation. Thank you.